Hi everyone. In my first lecture, I have discussed about how to transform a given current source into an equivalent voltage source and how to transform an voltage source into current source and how to replace if two voltage sources are connected in series with an equivalent single voltage source and how to replace if multiple current sources or if they are connected in parallel with a single current source. So next we'll see with the problems problems on source transformation. Let's take one simple problem. Let's take this problem. So first current source is 3 amps, 2 amps, 1 amps, 2 ohms, 2 ohms, and 4 volts. So across the terminals A and B. The problem is we need to convert this as an entire circuit into a single voltage source across the terminals A and B with a series resistance. So to solve this problem, say first step what I'll do, I'll convert this 4 volts. I'll convert this 4 volts voltage source into an equivalent current source. So if I'm doing it, rewrite the circuit as it is. So if I'm converting this into an voltage source, the polarities of the voltage source, according to that, I am writing this current direction. So we know that I is equal to V by R, which is 4 by 2, which will be 2 amps. 2 amps. And there is a connect that. And we can replace this 2 ohm parallel resistances into an single into a single with a single resistance, that is 2 ohms in parallel with the 2 ohm, which is 2 into 2 divided by 2 plus 2, it is 4 by 4, which is equal to 1 ohms. And this 5 amps. Across terminals A and B. So now these two current sources, that is 2 amps, 2 amps are in the opposite direction and with the same magnitude, hence they cancel each other. And this 2 ohm and 2 ohm, they are in parallel. So in step 2, in step 2, this 2 ohm will get going to cancel each other. And this 2 ohm, if I'm replacing with a single equivalent resistance, then I can write it as 1 ohm. And then this current source of 1 amp, which is in parallel with this 1 ohm. And this 5 amps across terminals A and B. Now what I can do, I can convert this 1 ampere 1 ohm current source into an equivalent voltage source. So in step 3, is 1 ohm. If I am converting this 1 ampere, 1 ohm, if I'm converting this 1 ampere into a voltage source, so V is equal to I into R, 1 into 1 will be 1 volt. With the same resistance, 1 ohm. Five amps across terminals A and B. So in my step 4, what I'll do, Now 1 ohm and 1 ohm are in series, so equivalent resistance will be 2 ohms, and that is in series with the voltage source 1 volts. So what I will do, I'll convert that into a current source. So which will be 3 amps, and this current source, I'm converting this voltage source into current source, that is I is equal to V by R, that is 1 by 2, it is 0.5 amps, with the parallel resistance 2 ohms. By amperes. Now in my last step, so now this 3 amps and the 0.5 amps, they are in the same direction. So they're going to add, we're going to add. So 3 plus 0.5 is 3.5, but 5 amps is the largest current source, but it's running in the opposite direction. So 3.5, that is 5 minus 3.5, it is 1.5. I'll go with the polarities of 5 amps, which is I2 minus, that is 5 minus 3.5, it is 1.5 with same resistance, that is 2 ohm across the terminals A and B. The last step, convert this into an equivalent voltage source across the terminals, because in the problem they've asked about to convert this entire network into an equivalent voltage source. So V is equal to I into R, 1.5 into 2, it should be equal to 3 volts across terminals A and B, and with the same resistance 2 ohms. So this is how we can do the problems on source transformation. So any complicated network given, analyze the network, and we can convert that complex network into a simple one through the converting an current source into a voltage source and equivalent voltage source into current source. Thank you. In my next lecture, I'll be explaining about the source shifting. Thank you.